Let's go. All right, so we're in this pair deck today, and this is going to be the limits of growth, and you guys have that limits of growth slide that is up there, and I had some responses on it for you guys to go on, and nobody has typed anything because I really didn't put a prompt into it, and that's fine. Limits of growth, so what causes populations to either expand or contract or change their growth? So let's go ahead and go to what limiting factors are. So in any system, in any ecosystem, we're going to have these different things in the system that allow organisms to either be successful or to not be successful. And these are going to be called our limiting factors. They essentially put stressors or pressures onto populations. So you can probably very easily come up with some ideas as to what every organism needs to be successful in its environment. Starts with an F, ends in an ood. Food, right? So all organisms need food. So if you don't have a lot, that is a limiting factor to the population growth. There's another one, starts with a W, ends in an otter. Water, yeah, you guys are so good. So sure. And then so if we're talking about food and water, then where organisms live, their shelter also becomes a limiting factor. Okay? So if we take into account all those limiting factors, then what we can do is we can come to how many organisms can be held into one ecosystem, and that is called the carrying capacity. Here you have two graphs. The first graph on the top is showing you a surplus graph of organisms in the good months in the northern exposure or northern hemisphere. The bottom graph is showing you carrying capacity. This is a standard carrying capacity graph. That blue line shows over time how many organisms the ecosystem can survive and how many they can hold. And by the time that we reach 1850, 1860, then those organisms have leveled out on a plateau. And once you reach that plateau, that is its carrying capacity. If this is our plateau, every once in a while, the organisms will go above and then below, and that's what you're seeing on that graph, the above and below of that particular sequence there. That means it's been a good year. There haven't been a whole lot of limiting factors, and so that we get a little overshoot, and then, oh, well, there's too many of them now, so what happens? There are too many, they crash and burn, but they never go all the way back to zero. They'll go down below carrying capacity and then up. And so carrying capacity, if you think of it in an ecosystem, is kind of like the average organisms that can be contained across that system based on all limiting factors. The red graph with the organisms, the outlines of the animals, shows you that when organisms reproduce, they reproduce a lot. So there's a thing called fecundity, F-E-C-U-N-D-I-T-Y, fecundity. And so when you're fecund, that means you produce a lot of offspring, but you don't put a whole lot of care or effort into them. Whereas if you're not, then you just give birth to one or two and you take a lot of care with those organisms. So organisms like fish, they lay 10,000 eggs and swim away. Good luck. Maybe some of them are passed on, maybe some of them survive. If you're an elephant, you give birth to one and you keep track of it for a very long time until it's a mature elephant. If you're a human, you might have a handful of kids, but you're going to invest some energy into them for a few years, hopefully more than 2 or 3, before you kick them out on their own to go take care of themselves. If you're a frog, lay your eggs, hop away. That's it. All right. So, and then you'll see that the limiting factors as we come on the downside of that red graph, starvation, disease, accidents, weather, hunting, predators, all those types of things, those are going to be the items that are going to make that come back down towards the carrying capacity. So you can see carrying capacity in 2 different ways on these 2 different graphs. All right. So sometimes, and this is one of the terms that we had from your Quizlet from this week. So that is a tick, that's a parasite. So parasitism, mutualism, commensalism, all those other things. These are based on how densely populated the organisms are. How close together are they? Well, ticks jump from one organism to the other organism to the other organism. If there aren't a lot of deer in the fields, the ticks fall off and then they can't find the next host. So if it's very dense, these things like competition, predators can find a lot more to eat, the parasites, the diseases, and then stress. If I took everybody in your household and told them that for the rest of their life they have to live in that cupboard, they're not going to be very happy, right? They won't fit in there, so they'll be stressed out. So if I tell a deer you're going to live in one field with all the other deer in one field, that's a stressor and that's a density dependent limiting factor. Correct. Versus density independent limiting factors, where you have weather or natural disasters, that it doesn't matter if you have 6 deer and it doesn't matter if you have 600 deer. When the fire comes through, it's killing all the deer. Yeah, but if it's a wildfire, they don't run far enough and fast enough. They get trapped. Correct. Killing organisms left and right. So these are density independent. They don't matter. It doesn't matter how many organisms you have. It's still going to burn that forest down. Right now, they've all either migrated out or been killed. Yeah. I mean, birds fly away, right? So birds are fine. But if you're a small toad, you're done, right? You can hop as far as you want, but you're not going to run away from a fire. Correct. Yes? Oh, yeah. No. No. Oregon. Washington and Oregon are experiencing fires right now. Hawaii, I mean, there's an eruption in a volcano, but that's all the time. This time of year. Yep. Okay. So why I'm doing this little mini lesson is because the lessons of the KBAB, which is number 2 for this week, is about carrying capacity. So with a little bit of introduction, a little bit of this mini lesson, this assignment is super duper straightforward now. Read through some of the sections, click off if you've read them or not, look at your data table, click off whether you've adjusted it or not, and then answer a couple of questions, and then the KBAB activity can be submitted and turned in, and then you're done for this one. Tomorrow, I'll do a quick mini lesson on the video questions, which is a little bit more, there's a big table that goes with. If you are working on that today, then I will happily help you with it as well. I have found what works really well going outside is if we just take some of our stools with us. If you take your stool with you, then you don't have to sit on the ground, and it's way easier to type with your stool on your lap than literally sitting down. I'm going to stop this recording. We're at 8 minutes, which is usually